Hello, welcome back to chapter 5, which is chapter 5. We are going to learn about normal distribution. In this chapter 5, I will be covering about 3 parts, so meaning that we are going to have 3 videos for each part, which is the first part. We are going to learn about the concept and the table, which is in this first video. We are going to learn about the concept of the normal distribution and also how to learn how to use the table of the standardized normal distribution to calculate the probability. And then the second part, and then in the second video, we are going to learn about the forward method, which is forward method is how we want to calculate the probability for the normal distribution. And then for the third part, in the third video, we are going to learn about the backward method, which is the backward method is we are going to learn how we are going to use the table of the standardized normal distribution when we already have the probability to find the value of our variable, which is to find the value of x. Alright? Okay, so let us move on to the first part, which is the concept and also the table. Before we go with the normal distribution, let us first discover or learn how can we come up with the normal distribution. Okay, so first, normal distribution. How does normal distribution looks like? Okay, so let us go back to our first, the cover for the chapter, which is this one. So if we can see that normal distribution looks like this one, the smooth line here, which is, it says that the bell curve. So normal distribution looks like a bell-shaped distribution. Okay, so normal distribution, also known as a bell-shaped distribution, which is normal distribution looks like a bell. Okay, alright, so that is normal distribution looks like a bell. Okay, so how normal distribution comes from, how it come from, where it come from. Alright, okay, so normal distribution comes from a histogram. Okay, so before we go with the history, the history of a normal distribution, first we need to know to calculate the probability using the normal distribution, it's for the continuous variable. Alright, okay, so we are going to use the continuous variable to calculate the probability using the normal distribution. Okay, so let's say we are having the height variable here and we are having a histogram for height variable. Okay, so we know that whenever we are drawing our histogram, our y-axis, we are using the frequency, which means that each of the bar represents the frequency for each of the classes. And the x-axis that we are having here, so the x-axis here shows that our variable, which is, it represents the height. So the value on the x-axis represents the value of the height. So let's say for the histogram that we are having here, the lowest height that we have in this distribution or in this histogram is the lowest height is 130 cm, and the highest height that we have in this distribution is 190 cm. Okay, so this is our histogram for the height. We know that for the height, we can have any value because it's a continuous variable. So any value that we can have in terms of in the interval. So whenever we can have any value, we can have 130 cm, we can have 130.00001 cm, we can also have 130.01 cm, we can also have 130.1 cm. So meaning that each of the value that we can have will be represented by a line on each of the x value, which means that for 130 cm, 130 cm will be here. if 130.00001 cm will be here because it's a very small gap. 130.01 will be here. 130.1 will be here. So meaning that each value within the interval from 130 until 190, you will have each individual line. So means that you will have each line. Since that you will have a very small line, so that's why you will come up with the smooth line. So you will have this smooth line, this. So that's why it will come up the normal distribution. So that's why you will come up with the normal distribution like this, bell-shaped distribution from the histogram. That's the history how the normal distribution or the bell-shaped distribution formed, how it is formed. Alright, okay, so after you know how it is formed, then we can learn the properties of the normal distribution. So the first property says that the total area or the total probability under the curve is equals to 1. So you know that the whole probability or the whole area under this curve is equals to 1. Alright, so that's the first property for normal distribution. The second property of a normal distribution says that mean equals to median equals to mode. Alright, so for the normal distribution, this one is a special distribution because normal distribution is a symmetrical distribution. Alright, so symmetrical distribution, that is a special thing about symmetrical distribution, which is the properties is mean equals to median equals to mode. Alright, so you will always get the same value of mean, median and mode whenever you calculate this value of measure of location for normal distribution. Alright, okay, so you know that the normal distribution comes from histogram. Okay, so if you still remember, mode is for the frequency which is the highest frequency. And you know that for the histogram, highest frequency is the highest bar. And for the normal distribution, highest bar is here. So that is the highest bar. Alright, okay. And also median is the middle point. Middle point is in the middle. So middle is also here. And mean, whenever you add all the value and you divide with how many data you have, you also will come up with a value in the middle. Because you are having the same amount on the right and left, and you have the same amount at the middle. So that's why you will come up with the value at the middle. So that's why for normal distribution or symmetrical distribution, you will come up with the value mean is the same with the median and also the same with the mode. So that is the second property of the normal distribution. Alright. So meaning that whenever you have the normal distribution, so the value in the middle here is going to be the value of the mean. And also the median and also the mode. Alright. So let us move on to the third property. So the third property of the normal distribution says that 50%, 50%. So what's the meaning of 50%, 50%? Okay. So you know that normal distribution, when we fold the normal distribution in the middle, so when we fold the distribution in the middle, we know that the total probability or the total area is 1 under the curve. So when we fold this distribution in the middle, each side we are going to have the same shape and the same size, which means that this side is going to be 50% or 0.5. This side also going to be the same shape with the other side, 0.5 or 50%. That means with 50%, 50%. Both sides, the green side with the purple side, will have exactly the same shape and the same size. Alright? Okay. That's the third property. And the last property of the normal distribution, the model or the notation of a normal distribution given to us with x. And so this one means that x here is our variable. So whatever variable we have, which means that the continuous variable. N here means that normally distributed. So let's say our x is the height. So height is normally distributed with mu. Mu here again, mu is the population mean with sigma square. Sigma square here variance. Population variance. Population variance. So let's say I give you this value. So let's say I give you x and 16. So now you know this variable x. So let's say this variable x is, we don't know what is the variable x. So we know that this variable x is normally distributed. Now we know this normally distributed is x variable is a continuous variable. Having the mu, which is the population mean, is 60. And having the population variable, population variance 16. Alright? Okay. So that means with the fourth properties, which means that the model or the notation of the normal distribution. Alright, okay. So after we know all the four properties of the normal distribution, now our objective using the normal distribution here is we want to calculate the probability of normal distribution. Alright, so we know that when we have a normal distribution, what we want to calculate is the probability. And we know that the probability is the area under the curve. Alright, okay, so let's say this is a normal distribution about the height. So let's say this is about the height. Okay, alright, so let's say we know that the height, the lowest height is 130 cm. The highest height is 190 cm. And we know that the mean of this height, which is in the middle here, the mean is 160 cm. Let's say we want to know what is the probability of the people having the height from 137 cm until 145 cm. So 137 might be around here. So this is 137. 145 might be around here. So this is 145. So what we want to know the probability is for this area. So what we want to know is what is the probability for this area. Okay, so that is our purpose. We want to know the probability for the area under the curve for normal distribution. So it's not necessary only for this area. We can know the probability maybe for this area. We can also know the probability for this area. We can also know the probability for this area. So wherever the area that we want to know for the probability for the normal distribution, so that is our purpose for this chapter. Okay, so to know the probability, to calculate the probability for continuous variable for normal distribution, we need to use the standardized normal distribution, which is standardized normal distribution looks like this. Okay, which is, it says that the notation or the model for standardized normal distribution given with Z normally distributed with 0 and 1. So again, we know that whenever we have n normally distributed, so now whenever we have Z normally distributed, now it's no longer normal distribution, it's now is standardized normal distribution. So when we have now is Z normally distributed with 0 and 1. So whenever we have Z here, so it's no longer normal distribution. Now it is standardized normal distribution. So now we are going to use this standardized normal distribution to calculate for the probability. Alright, so again we know that in the bracket, the first value here is the mean value. And the second value here is the variance value. Okay, so for standardized normal distribution, the mean value will be always 0. So mean value for standardized will be always 0. Alright, so look at the standardized normal distribution chart here, graph here. Okay, so again, the mean is always the middle line for the standardized normal distribution. And the value will be 0. Alright, okay. And the x-axis for the standardized normal distribution, we are no longer going to represent it with x. We are going to always represent it with z. So now we know this z represents the standardized normal distribution. So this z value, this one, we call it as z score or z value. Alright, so any value along the x-axis inside the standardized normal distribution, this value is z score. Alright, and using the standardized normal distribution to calculate the probability, so this one, we are going to use the table of standardized normal distribution. So the table of the standardized normal distribution, I'm going to use it as SND. Is provided in our table in the formula booklet. Later I will show you. So this table is always given to us the probability using the positive value of z score, and the probability is always less than the probability less than the z score. So if you can see that here, let me draw you another distribution of a SND. So let's say you have this SND. Okay, so you know that the middle line of the SND is 0. Okay, let me draw you another one on another distribution, on another page. Okay, so let's say you have your SND here. Okay, so you know the middle line, so this is SND, standardized normal distribution. Okay, so standardized normal distribution, you know that along the x-axis, this is no longer x, this is z, which is z score. And whenever you have SND, the middle line or the mean value for SND is always 0. Alright, so when you have 0 for the middle value, when you start from 0, when you go to the right, this one goes to the positive side, which means that here you will have positive 1, here you will have positive 2, here you will have positive 3, go on, so on, so on, so on. But when you start from 0, when you go to the left, here, so here you will have negative 1, here you will have negative 2, here you will have negative 3, and so on, so on, so on. Alright, so that is the symmetrical distribution. It's still symmetrical distribution, but it's standardized normal distribution. Alright, okay, I will erase this one. Alright, okay, so the probability in our table given to us that we are going to use in our syllabus is always given to us the positive value of z score, which is the positive value of z score is always on the positive side. So let's say the positive is somewhere around here. So let's say with the positive value of z score, let's say it's 8. There is a positive value of z score. Okay, and the shaded area, which is represents the probability, is always lesser than the A, which means that lesser than the A is this area, lesser than the A. Okay, so the whole probability here, that is the probability given to us in the table. So if we are having the same shaded area in our question later, so we can straight away refer to our table for the probability distribution. But if our shaded area in our question is not the same with the table shaded area, we need to do some adjustment. So I will teach you later for the adjustment. Alright? Okay, so that is for the standardized normal distribution. Alright? So, I will see you in the next video. I'm sorry because my limit for the video is only for 30 minutes. So, I will see you in the next video for how to use the table to calculate for the probability. So, I see you in the next video for using the table to calculate for the probability.